Okay. Hello, good morning, students. We'll start now. Okay. So the previous lecture classes I have just. Can you hear me? Can you hear me? Okay. Then previous class I have just uploaded the recorded lecture note into the LMS. So that means ferrous. Sorry. That means ferrous metals and non-ferrous metals. So those things I will again discuss in the later sessions. Okay. Today we'll discuss about the heat treatment of metals. Right. So anyone heard about this word heat treatment? Anyone heard about this word heat treatment? So heat treatment process or the metal heat treatment? Yeah, heat treatment means this is a manufacturing. There are a lot of types of manufacturing process available. You can cut the metal, you can use the welding, or you can use the carpentry work or wood works, right? Sheet metals works. These are called as manufacturing process, right? So before you are going to the manufacturing process, you have to do some treatment to the metals, right? What are the treatment? Heat treatment process. So why you need this heat treatment process? Why you need to do the heat treatment to the metals? You need to, normally metals has some properties, internal properties, but you need to change the internal properties for your different applications. In that case, you need to change the properties of that particular metal. So to change that properties, you have to do this heat treatment process. So this is the purpose of doing heat treatment of metals, right? So in this lecture, what are the heat treatment process available, how we can do the heat treatment process, procedures, applications, properties of that heat treatment process, those things we will discuss in this lecture, right? Okay, so normally heat treatment is, we just discussed, heat treatment is a process using heat. You are doing a treatment using heat. That's simple thing, right? You are doing a treatment to the metals using heat. That's why it is called as heat treatment, right? And why you need to do this heat treatment process? Purpose of this heat treatment process? To change the physical properties. That means microstructure of that metal, right? So to change the physical properties of that particular metal, right? So it can be softness, hardness, wear resistance, uh, like tensile strength or stress, welding ability, machining ability. So these are the physical properties. To change that particular property, you can go for this treatment, right? But commonly, this heat treatment process has three phases or the three steps, right? What are them? First, heating of the metal, soaking of the metal, and cooling of the metal. So these three functions or these three process have been done during this heat treatment process. Okay. So if I just ask you to draw the diagram or draw the curve, that means temperature versus time diagram for this heat treatment process. How it can be possible? This is a y-axis. You can indicate this y-axis as a temperature axis, right? So this is a x-axis. You can indicate this x-axis as a time, right? So your task is you have to draw a graph indicating this heat treatment process. That means you have to indicate heating, soaking, cooling, right? How it's possible? You are having metal in your room temperature, right? Then you are heating that metal to specific temperature T1, right? So what will happen to the temperature of that metal? You are heating that metal to a specific temperature. Okay. Then soaking of the metal. Soaking of the metal means you are heating that metal for a particular time period. So temperature should be constant. It's a horizontal line. Then you are keeping this for a particular time period, right? Then cooling of the metal. That means the metal's temperature is T1. So you are cooling that metal. So this is. So this one is first phase heating process. Then this one is second phase soaking process or the keeping holding process. And this one is cooling process. Third one, it can be or you can say cooling process or the quenching process, right? So these three phases available. These are the main phases available in this heat treatment process, common phases, right? Okay, in other way, I can just explain. Okay, you have metal A, right, with your hand. So you have to do the heat treatment process using these phases, right? So you have to do the heating process, soaking process, cooling process, right? So what you need to do is first you have this metal. So you have to, at first you have to do this heat treatment process. So that means you are heating that metal to a specific temperature. So here heated metal is available, right? In here, so this heating process can be done in particular place or the anywhere in the medium, right? So place mean you can use the furnace. There's a equipment that is called as furnace. So inside the furnace, you can keep that metal and then you can do this heating process. Then you are brought to this heat treatment process to the soaking process. Soaking process means what you are doing here. So here predefined temperature T1. So you are heated that metal to that temperature. So here also temperature level is T1, right? So predefined temperature. So then you are keeping at this temperature for a specific time. So that is called as soaking of the metal, right? Then this metal is existed from the furnace. So you are taking that metal away from the furnace and then you are doing the cooling process. So cooling or the quenching, this is the third step. So in here what you are doing is heated metal is cooled here, right? Heated metal is cooled to another distinct temperature because it can be in any temperature level, but it should be lower than this particular T1, right? Then your heat treatment process is finished. But sometime you need to fine tune that physical properties done during this heat treatment process. So to fine tune these physical properties, you can again do this process, heating, soaking, cooling, right? Then this metal, this this metal is again loaded into the furnace for this heating process. So the second stage will be started. So this is the Hohmann heat treatment process, right? Here, heat treatment furnaces, right? Heat treatment furnaces mean, so these furnaces kind of an instrument. You can use these furnaces for the heating processes, right? So if you want to heat the metal, you can place that metal into this furnace and then you can continue the heating process or the soaking process. So it can be different types. So liquid bath type, salt bath type. So these are the bath furnaces. That means inside the furnace, if you are using oil, that is called as oil bath furnace. Or if you are using salt, molten salt, then it can be salt bath type. So likewise, there's another type, stationary type, movable type. Movable type means it can be rotated or it can be like car button type, right? So that means these are the furnaces can be moved, right? So in question, sometimes there may be a question like list down 5 different types of furnaces that can be used for the heat treatment processes, right? Then you can write any of these furnaces, right? Okay. This is the important part of the heat treatment process, right? So constitution of iron and steel. That means these, according to the, when you observe these steels microstructure using any spectroscopy, if you observe the microstructure of that steel, you can identify or you can classify that steel into further 5 classifications. It can be ferrite, cementite, austenite, pearlite, martensite. These are the main 5 constitutions. How you can classify this? Using observing their microstructure, right? So it can be like this way or it can be like this layered form, or it can be like layered form but with huge gap difference, or it can be like needle like structure. You can see the needles, right? So these are different microstructures of these five main constitution. According to this different structure, you can classify this constitution. How you can classify this? Normally, steel has iron and carbon, right? But in the case of ferrite, it has iron, but it does not have carbon, right? That means, oh, it has very little amount of carbon available in this ferrite. But in the case of cementite, it has carbon. When you compare with ferrite and cementite has higher amount of carbon or the percentage of carbon than this ferrite. So these are the difference. So if you see this austenite structure can be formed only higher temperature position. When you heat that metal at higher temperature only, that structure, microstructure of that steel changes to this austenite form. But in the case of pearlite, it is like this laminated structure, right? Or if it is a martensite, it is a needle-like structure. See here, one kind of pearlite structure. So these are the stacked form or a laminated structure, right? So these are the difference. So how you can classify this? Using or when observing this microstructure. So according to this carbon or the iron amount of carbon available in this constitution, properties are different, right? Austenite properties and pearlite properties are different, right? So these are the five main constitution available in this steel. Okay. The next topic is allotrophy of iron, right? Allotrophy of iron means yeah, do we have to memorize this microstructure of steels? I mean these patterns of constitution. That means you ask these things. Yes, there may be question. List down five main types of constitution of steel. There may be one question. So you have to write these ferrite, cementite, austenite, pearlite. Or in other way, how you can identify five main types of constitution of steel, or how you can identify the constitution of steel. So you have to write with observing their microstructure. This is another question. Or there may be other question. Briefly explain or list down three main constitution of steel and briefly explain those constitution. Then you have to select three of them and then you have to write these things, right? So it's important. Another topic is allotrophy of iron. So here in the left side there's a diagram, right? But what it means is you are heating that particular metal to a higher temperature. Yeah. Yes. At the end of this lecture, I'll explain about the assignment, okay? So this allotrophy of iron means you heated that metal and so heated to the higher level of temperature. So that means around 1700 degrees Celsius, right? Then what you are doing is you heat it. Now liquid form of that metal available or the molten metal is available at this stage. So what you need to do is that metal or the iron, specifically iron, that iron is cooled from this molten condition to the solid state. So you are cooling down that particular molten metal, right? So in this case, what will happen when you cool down this metal, the temperature of that molten metal becomes low and it start to become solid state. So you are cooling down, it continuously cooling down. So it reaches to this specific temperature 1539 Celsius. So when it reaches this temperature, delta ion is formed, right? So this delta ion available in between this 1539 to 1404, right? So you are then again cooling down that temperature or cooling down that ion. Then it reaches this 1404. So once this reaches this temperature, again this delta ion is converted to gamma ion, or the formation of this gamma ion will be started. Okay. So this gamma ion is available in this 1404 degrees Celsius and 910 degrees Celsius. So you are cooling down this temperature, so gamma ion available. Then that gamma ion reaches to this 910 degrees Celsius. So then once this gamma ion reaches to this 910 degrees Celsius, beta ion formed. Right, that means gamma ion is converted to this beta ion. So then again beta ion cool down, again continuously cooling down, and then it reaches to this 768 degrees Celsius. Right. So in between these two temperatures, beta ion is available. Right. Then once this beta ion reaches to this 768 degrees Celsius, then again alpha ion is forming. Okay, so that means there are four phases available, or the four changes happening, or four allotrophic changes happening during this cooling down process. What are them? First change occurs at this 1539 degrees Celsius. So that means delta ion forms. So the delta ion start to form. Then second changes is 1404 degrees Celsius. So at this place, this delta ion starts changes into this gamma ion, right? So then again, third changes occurs at this 910 degrees Celsius. So what will happen is this gamma ion starts changes into this beta ion, right? Again, this is a third changes, then fourth changes that takes place at this 768 degrees Celsius. So in this place, this beta ion starts changes into this alpha ion. Right? So these are the four allotrophic changes happen when ion cooled from this molten condition to this solid state. So there may be a question. Explain the allotrophic changes occurs when this ion cooled from the molten condition to solid state. So remember it, you don't need to draw this diagram. You don't need, right? But you need to remember it. These 4 changes, and then at what temperature level these changes occurs, and then what's the changes? Delta ion form, delta to gamma, gamma to beta, beta to alpha. So these 3 things important. So you have to remember it. But this graph you don't need, and this structure also you don't need. Yes, microstructures are changing because normally we have discussed here austenite structure form at high level of temperature, right? Perlite structure formed at low level of temperature. But here this molten condition austenite structure, but in this condition ferrite or the perlite structure. So this microstructure level is changing, but you don't need at this moment microstructure because this due to this 2 things, due to this temperature level and amount of carbon available in this metal or the steel, right? So only you need to remind it these 4 changes and which temperature level these changes occurs and how many changes occurs when you cool from this molten condition to solid condition, right? But this alpha ion internal structure is different than delta ion internal structure. That's why it's mentioned here body-centered structure, face-centered structure. But these things you don't need at this moment. Okay. Okay. This is another important topic. Up to now, if you have any doubts, do you have any doubts? Up to now, what we discussed. Okay. So this is another topic, important topic, iron-carbon equilibrium diagram, right? So this iron-carbon equilibrium diagram has been drawn like temperature versus amount of carbon available. That means percentage of carbon. Yes, allotropy structure mean you mean this structure. Yeah, this one you need to remind it. That's what I just told you. You don't need to remind this graph, but you and this microstructure, you need to remind it how many allotropy changes occurring, and then what are the changes occurring, and in which temperature level this changes occurring. These 3 things important. There may be questions in your examination, right? Okay, then we'll continue this iron carbon equilibrium diagram. So this is the temperature versus amount of percentage carbon available graph, but this is a complex, this is the fully complex iron carbon equilibrium diagram. This is what happening when the percentage of carbon increasing or when the temperature of that steel increasing. But in here there are some important points. That thing only you need to understand and you need to memorize it. What are them? So this is a iron carbon equilibrium diagram. So y-axis is denoted as temperature, x-axis is denoted as carbon percentage, right? Okay, axis plotted. Now there are some. So in the previous slide we have discussed about constitution of iron, right? What are them? Austenite, pearlite, martensite, ferrite, right? Cementite. So these 5 important main constitutions are important to draw this iron carbon equilibrium diagram, right? So you have to remind it. So just draw like this triangle. Then draw a horizontal linear line, right? Then draw this V-shaped line. And here draw this vertical line. This is a simple way or a simple form of this iron carbon equilibrium diagram, right? Okay. Now we'll indicate the constitution available in this diagram. First thing, ferrite. Ferrite, we just discussed, ferrite has very little percentage or a very little amount of carbon, or a ferrite does not have any carbon compound. So this triangle, in this phase, ferrite is available. Okay, so this is ferrite. Second thing you need to remind it, at higher level of temperature only austenite structure formed. We discussed earlier. So remind it, this is a horizontal line, temperature line. There's a two phase, this above this phase, this above this line phase, and below this line phase. So austenite available above this line, right? So it can be like this, above this line, austenite. So austenite, other thing, austenite can be pure form, pure austenite, or the mixed with other constitution, right? So see here, this is a V-shaped curve, right? Above this V-shaped curve, these are things. This is a pure austenite structure available in this phase, right? But we just discussed above this line austenite or the austenite plus any other constitution. But in this phase, austenite available. So here, this phase, what is that? Mixture of austenite plus ferrite. This is a pure austenite structure available in this phase, in this temperature levels. In here, ferrite plus austenite structure available. In here, austenite plus cementite available. This is a mixture of austenite plus cementite available. In other way, you can remind it, there's a horizontal line here. right side of this horizontal line in this space, cementite or the cementite plus mixture available. Left side, perlite or the perlite mixture available. So that's why in here cementite plus austenite, right? So here cementite plus perlite available. Here perlite plus ferrite available. So you have to remind it. You have to draw a graph. Put axis temperature y-axis, x-axis percentage of carbon. Then draw this V-shape or triangle and draw this horizontal line. Then again V-shaped line and then draw this vertical line. Finished. Then indicate the constitution available. Above this line, austenite. Below this line, perlite. So here, austenite, pure austenite. Here, pure ferrite. Here, ferrite plus austenite. Austenite plus cementite. Here, cementite plus perlite. Here, perlite plus ferrite. These are the 5 main iron-carbon equilibrium diagram with indicating 5 main constitutions. So this graph that they draw here is important. So if you need, note it down. Right? Other thing is important. This horizontal line is called as critical temperature line, right? Because it does not depend on the percentage of carbon available, because with increment of this percentage of carbon available, the temperature does not change. So that is called as critical line. That means lower critical line. So that temperature is 723, right? So that one you need to remember it. Okay, so these are things explained. I have explained here. Then line PSK means this horizontal line. So this one is 723 degrees Celsius. And what will happen here with percentage of carbon available or the carbon content does not affect this lower critical temperature. So this temperature line is important, right? These are the explanation of this iron-carbon equilibrium diagram. So once in the examination, sometimes there may be a question, just draw the iron-carbon equilibrium diagram indicating 5 main constitution of steel, right? So you have to draw this diagram with this indicating, and you have to indicate this temperature of this lower critical line, right? No need to indicate other temperature line, but this lower critical line you have to indicate it, right? Do you have any doubts? Do you have any doubts? Okay, then we'll move to the next slide. Next is objectives of heat treatment. What's the purpose of doing this heat treatment process? So, to by heart this one, it's easy ways. You know the heat treatment process. What it means? Yeah, it's a process using heat, right? So, what's the main purpose of this heat treatment process? To change the internal structure or the physical properties of that particular material you are doing heat treatment process. So you have to remind these two. And third one, you have to remind it what are the physical properties available, because to change the physical properties you are doing this heat treatment process. So what are the physical properties available? You have to remind it: softness or the hardness, internal stress, horizontal resistance, and wear resistance, ductility, strength, toughness, electrical property or the magnetic property, or shock resistance, welding ability, casting ability, machining ability, or the machine ability. These are the things, physical properties. But main objective is to change the physical properties of that particular metal. So that one you have to remind it. And you have to remind what are the physical properties of that metal. Now, you can write, using that two things, you can write down the objectives of heat treatment process. To increase or reduce the resistance horizon, to improve the reduce the ductility or improve the strength, or the you have to include improve, increase, reduce. These three words to that physical property, and then you can write down the 10 to 15 objectives, right? These are the important things. There will be questions, right? These are the objectives of heat treatment process. So do you have any questions up to now what we have discussed here? If not, we can move to heat treatment process. The methods, the way of heat treatment process. No, you don't need to memorize exact percentage of that mean amount of percentage of carbon, but just in case, just in the previous lecture notes, there may be slides like different types of low carbon steel and medium carbon steel and high carbon steel. So what's the difference? Means low carbon steel has very less amount of carbon. High carbon steel has very high amount of carbon. So likewise, you have to remind it, but you don't need to remind this particular percentage, 67 percentage or 65 percentage likewise. Grain size means, so as I discussed earlier, internal structure has components, carbon, iron, likewise. Those are the grain called as grain size, right? Internal structure component size. So gap between those elements. Understood? or simply say particle size, right? Okay, so shall we move? Okay, there are different types of heat treatment process available. Normalizing process, annealing process, the hardening process, or the tempering process, right? So these are different types of heat treatment process. You can use this process according to your purpose or your different applications, right? Okay. So normalizing means normal common heat treatment process. We discussed earlier, heat treatment process has 3 stages. What are them? Heating, soaking, cooling. So normalizing process also kind of heat treatment process. So it also has that same 3 process or the same 3 stages, right? So if I draw this temperature versus time graph here, right? Heating stage, then soaking stage, and then cooling stage. First stage, second stage, this is third stage, right? So what I doing during this heating process, first process, you have steel, right? So what you are doing is you are heating that steel, so that steel is uniformly heated to the temperature, specific temperature T1, right? So the steel is uniformly heated to that temperature. So therefore you heat it to high level of temperature. So therefore it forms austenite structure, right? At this heated level, austenite structure formed, because we discussed earlier, austenite structure can be formed only at high level of temperature, right? So you uniformly heated or heating that steel to a specific temperature, so therefore it causes austenite structure, right? Then second phase is scalding phase or the soaking phase, right? Second stage. So what you are doing here is that heated steels are held at this constant temperature for why? To complete that homogeneous structure, because austenite structure is forming at this level. So to complete this homogeneous structure, the steels are held at this constant temperature, right? So if I say just around 25 milliliter of millimeter diameter or the thickness of that steel, if you have 25 millimeter of that thickness or the diameter of that steel, then around 1 hour, so you have to keep that steel for a 1 hour period, right? This is just common calculation, right? So if you have 25 millimeter steel, that can be diameter or the thickness, then you have to keep that heated steel for a 1 hour period of time, right? So holding process or the stocking process finished. Now third stage, cooling process. Here, that steels are allowed to cool to a specific temperature, but that specific temperature should be room temperature, right? So that means that steels are allowed to cool at a room temperature, right? So usually this will be cooling process will be done in the air medium, right? Air means atmospheric condition, atmospheric air, right? So these things are important. Where cooling is done and to what extent or to what level of temperature you are heating that metal, right? So these steels are allowed to cool at a room temperature and usually in air. Other thing, so second method is called annealing. So when you compare this normalizing process with annealing process, this cooling process is, normalizing process cooling is faster than annealing, right? So you heated that metal, so austenite structure formed. Now you cooled, so then this austenite structure formed pearlite structure. That pearlite structure should be fine pearlite, right? This normalized steel is fine pearlite structure. So this one important, right? During the normalization process, austenite structure is converted into the fine pearlite structure, right? So fine pearlite structure means if it is a cross-sectional of that metal, so when you observe through the spectroscopy, you can see that microstructure like this. This is the fine pearlite structure. Laminated way or a stack form, right? So this one important. What you are doing the cooling process in air medium, then austenite structure formed to fine pearlite structure, then this is the fine pearlite structure, right? So objective, as I same as previous, these are the two. Obtain these objectives, you are doing this normalizing process, right? Okay, so this one is temperature versus percentage of carbon graph indicating this heating temperature ranges for this normalizing and annealing. So first we'll discuss the normalizing process. Normalizing process, this is the normal iron carbon equilibrium diagram. So this horizontal line is lower critical temperature line. This is the V shape. See here, normalizing can be done in this phase. That means only above this V-shaped line. That means this line temperature plus 50 and this line temperature plus 50 only. Normalizing you cannot do up to this level. Just only you can do this normalizing process. This line temperature plus 50 range and this line temperature plus 50 range only. Right? So that one important. You have to remind it. So next one is annealing process. So this one also heat treatment process. So, and same as normalizing, this annealing process also has these three stages. So if you draw the temperature versus time graph, it has heating, soaking, and cooling process, right? So you are heating that metal to a specific range. So austenite form is formed, right? Then you are holding that steel at this constant temperature. Why you are holding? To get the uniform particle or the grain size, right? Then again you are cooling that metal. So if you, according to your application or the purpose, your cooling rate can be different. So it depends on the applications, right? So once you cool down this steel, austenite structure converted into this perlite, but that's a coarse perlite structure. But normalizing is austenite converted into the fine perlite, but in the case of annealing, austenite is converted into the coarse perlite, right? So therefore, coarse perlite is formed. Therefore, this material you received from the annealing process is very soft. That means steel is becomes soft, right? But the disadvantage when you compare with the normalization, normalizing cooling process is faster process. Therefore, this annealing process is, it takes more time. And other thing, normalizing condition, you are cooling that steel in the air medium, right? But in here, you are not cooling that steel in the air medium. You are cooling that steel inside the furnace, right? So you need to prepare the furnace. So therefore, cost high, right? When you compare with normalizing. So these are the two major disadvantages, right? And other thing, this annealing can be classified into two types, right? One is full annealing, other one is process annealing. So full annealing means, just see here, see this picture. I explained normalizing means this temperature line plus 50, this temperature line plus 50. But full annealing means this temperature line, so in here, right? In this, above this temperature line, and then above this lower critical temperature line, right? So full annealing can be done at this temperature ranges, right? This is a full annealing, but process annealing can be done below this critical line. That means in this temperature range, right? This is the difference between full annealing and process annealing. Both the annealing process during full annealing can be done above the critical line, low critical temperature line. Process annealing can be done below the critical temperature line, right? Up to now, if you have any doubt. Do you have any doubts? Okay, since you don't have any doubts, we'll move to this, right? So, and important thing, this is a theory subject. Anyway, you have to by heart these things. At the day itself, just take a short notes and then memorize it. That's a simple way, because this is a 3-credit subject. So it's better to study that day itself. Then that will help you to get more marks. But usually 50% of percentage marks depends on your continuous assignment and then laboratory works. Other 50% of marks for your written examination. But in this situation only, we couldn't conduct your laboratory work. So once you come to the faculty, then we'll do this laboratory work. So until then, we'll discuss the theory part of that or the manufacturing process. Okay. So anyway, this is a by heart and subject theory. So you have to remind it. And other thing, up to now, if you have any doubts, you can talk to me or you can chat. Then we'll discuss. Then so this continuous assignments depends on the subjects. So this time, this COVID situation time, all the person evaluation criteria is different than normal criteria level. So that's different than what I said. But for you, as usual, so without considering COVID situation, normal evaluation process for your subject, basic manufacturing process is 50% and 50%. 50% for the written examination, next 50% for your practical session, because uh, all the cutting, lathe, carpentry work, metal, sheet metal work, or the carpentry work mean woodwork, welding works, everything you will be have the practical laboratory sessions, right? So last time we have done 8 laboratory works. So that means 8 laboratory days for 8 hours per day, right? So that's why 50% is allocated to the laboratory works, right? If you yeah, heat treatment process for the all types of furnaces. So sometimes in case for the other hardening processes like that, you need to do the oil bath type or the sometimes water condition. So that one in different purposes you have to do this different furnaces, right? So just at this moment you don't need the structure of the furnace, what are the things you are doing, because the heating process also different. In some cases you can add hock and limestone to heating the process. So sometimes you need to do the chemically heat the metal, or in the another case hardening process or other things you need the electrical or the current to heat the metal. So the heating process also, procedure of the heating stage also different and the furnace also different, right? Yes. So this hardening, there are two things we have to remaining to discuss about the heat treatment process. Other two process, one thing is hardening process, other one is tempering process, right? So hardening process and tempering process we will discuss in the next class. Okay, assignment. So any doubts? Any doubts? If you have any doubts regarding your first assignment, you can ask now itself. Yeah, so this is the your assignment. It is a case study. So that means you know the environmental pollution. So it can be soil pollution or the air pollution or the water pollution. So in this case, you have to remind or you have to consider air pollution and water pollution only. And other thing, you have to consider pollution by metals, right? How these metals can cause air pollution and water pollution, and especially in Sri Lanka. So in Sri Lankan conditions, so Sri Lankan situation or the Sri Lankan environment, how these metals pollute the air and the water, right? So these things just get at least 5 points and way of polluting the air and the water, and list down 5 and then explain about that pollution, right? So that is the assignment, but don't Google it, right? So the main minimum 5 ways you have to write it. Then explain that 5 ways in which ways this metal pollutes the air and the water, right? It's mean at least 5 ways or the sources you have to write it, and consider only air pollution and water pollution. Don't write other pollutions, and by metal also don't write other things. And especially in Sri Lanka, don't Google it. Case study means just look into his Sri Lankan system and Sri Lankan environment, get the idea and write in your words. Right? That's important. And so 5 ways, so minimum 5 pages or 5 papers. So because you have to write 5 pages, minimum one, and maximum is 10. So don't go for a more than 10 pages, right? No need. Think and important things only write it down. Okay, that's second thing. Third thing is you can add any pictures or that's your option, up to your wish. You can write any pictures or you can draw any flow chart if you need to describe the pollution, or if you need you can draw the diagram or the schematic diagram. Whatever it is, you can add it. Okay. Other thing, cover page is important. In the cover page, you have to have margin, right? Second thing, title of the assignment. Third thing, your index number, your department, and your name. Okay, these are things important. And there's a link available in the LMS. You have to submit your assignment through the link given in the LMS, right? Don't send through the email. If you have any problem while you're submitting, just contact me, right? Other thing, when you upload the assignment, the file name should be your index number and your name, right? Then that will be help to identify the person, right? Other thing, don't copy from others and don't copy from internet, right? Ideology, your idea, just right? It's needed. I'm not going to mark hardly, but don't copy, don't Google it. Just see it in the TVs and everywhere. They are mentioning about the pollution, right? So just think about just as an example, if I say just agriculture feed, pesticides, fertilizers, right? But indicating the metals, how the metals pollute. So that's thing important, right? Word limit means not a word limit, just minimum 5 page important, maximum 10 page important, maximum 10 page. Don't exceed more than 10 page, right? So not a word limit, just pages limit, right? Any doubts? And you have to consider the Sri Lanka situation. Yes, you can do the handwriting. If you do the handwriting assignments, then you can take a photo or you can scan using the phones. There's option using phones, so you can do this, right? Yeah, you don't need any prototype about the case study. That's it. I'm explaining. Just don't think too much about the case study. Just title, think, watch around your environment in the Sri Lankan system using newspapers or the TVs or the just talk with your family people. Just talk it and get the idea and write it down. That's it. Right? Just minimum 5 points. So 5 points enough. If you like to write, you can write more than 5, but 5 points is enough. I will mark only for the 5 points. Any questions regarding this? Yes, that's what I told you earlier. It is okay to add photos, images, or the schematic diagram, flow charts, whatever the way, in whatever the way you can interpret or that you can explain your study. Any questions? Any questions regarding this assignment? Your basic manufacturing enrollment case. Yeah. $20 ETC 1153. That means your course code and 20. You have to put a 20 in front of your course code, but don't give any space in between these letters. And ETC should be capital. So this is your enrollment key. If anyone's struggling to enroll the subject, help them or ask them to contact me. Okay, hope you don't have any further questions. Okay, so we'll wind up the session now and then we'll continue the hardening process and tempering process next class, right? Okay, shall I wind up the session? Okay, if you have any further question, you can feel free to contact me through the LMS or the Gmail, right? Okay, stay safe. Bye.